Okay, we're going to look at imaginary numbers, but one thing I want you to notice first is what's the big idea? Why do we need these imaginary numbers? The biggest thing I want you to get is you know that the square root of 16 is 4. We're all good with that, right? But the square root of negative 16 is 4i. That negative comes out of a square root as I. This is the biggest reason you need it when you use a quadratic formula and different things. We need to be able to get to an I. So let's look at this. We'll go now to your notes. What is I? I is the square root of negative 1. It's that simple, square root of negative 1. So what is I squared then? It's negative 1. Okay. You kind of need to recognize that. And where that really falls in is you knowing that if I have I times I, which comes up in math a lot, that's I squared. And if you see an I squared, you're going to replace it with a negative 1. Okay, so the square root of negative 5, we don't know the square root of 5. It's just the square root of 5, but we can pull that negative out. Square root of negative 16 is 4i. Okay, those are the big ideas. The other really important feature of an imaginary root is i's always come in pairs. So if you have one I, you have two i's, right? So if negative 3i is a root, then positive 3i is a root. And think about that. When you have the quadratic formula, it's negative b plus or minus the square root, correct? So anytime we have an imaginary root, we have two of them. If 5 plus 3i is a root, then 5 minus 3i is a root. I want you to notice that this is the only part that changes. It switches up. We don't change the sign with the 5. Okay, if it's 5 or negative 5, that stays. We only change the sign here. And where did this really come from? The quadratic formula, which is what? Negative b plus or minus the square root. And that's where that thing came from, right? So now we're just going to practice a little bit with these i's. Okay, so if we're simplifying and we add or subtract, do they behave like variables? Yes. So this would be what? 2 minus 5, which is negative 3. 7i minus 6i, which is I. That's it. If you FOIL them, do they FOIL just like regular letters? Yes, except for when you square them, you replace with negative 1. So 3 times 2 is 6. 3 times negative I is 3i, negative 3i. 4i times 2, 4i times negative I, 4i squared. Yes, it's multiply. So if you look at this, you get 6 plus 5i minus 4i squared. I want to focus on that. What is the outcome of a number next to I squared? Well, I squared turns into negative 1. And what's negative 1 times negative 4? Yeah. So in your mind, if you see minus 4i squared, it becomes plus 4. If you saw plus 7i squared, it would be minus 7, right? It just changes. The outcome of an I squared is that it changes this sign. So we really have 10 plus 5i. And I want you to notice that we always write the real part of the number. This is a complex number. You remember that? It's got real and imaginary parts. The real part always comes first. We don't write 5i plus 10. We write 10 plus 5i. Okay. This one, you can FOIL it or use your calculator. I wanted you to notice that there's an I on there. It is second period. The second period button is an I. So see, it will do it for you. So I is second period. Can you plug in what?
Like on your calculator, you also like root -1.
If you wanted to, but that, I guess. I don't know. I've never tried that. I would use the I, so you stay in I. Okay. Oops. What was that answer? And you can always do it by hand. We are not going to do a million of these. Like I said, the biggest thing I want you to recognize is that there's two roots and the square root of -1 is I. So when we take the square root of a negative number, it has an I next to it. Can you write the equation given double roots, right? Well, if I gave you a root of 3, you would say x minus 3. So what's the root here? X minus 2i, x plus 2i. And then if 1 is a root, what's that factor? X minus 1, right? Now it says double root, so we know that's squared. True? Now, can you FOIL this out? You can FOIL that out, right? So let's see what this really is. Let's FOIL that out. Now, what is x minus 1 squared? Right? We can FOIL that in our head. We've been doing those a long time. Now, what will this one change into? This, an I squared is -1, so this is really what? Right? True? Now, can you multiply those together? I'm going to, sorry, y'all, I have to rewrite up here because you know I write too big. Now, how do we multiply a trinomial times a binomial? You just take the x squared, multiply it through, then take the 4. And let me show you how I like to line these up so your math is easier and you don't end up with a string of numbers that's a mile long. X squared times x squared is x to the 4th. X squared minus 2x cubed plus x squared, right? Now I'll take the 4 and do that and line them up. If you'll be like this, then you immediately see how they line up and you can add like terms. So that is x to the 4th minus 2x cubed plus a 5x squared minus 8x plus 4. Okay? When you use the roots and you make an equation, the equation's going to look normal. Now tell me, what does it mean because you got these imaginary roots? What's the picture going to look like? Yes, there's going to be a spot where it's not crossing the x-axis. So punch that into your calculator. I want you to see what it looks like. We want to have clues. Since we had imaginary roots, we know there's one spot that's not going to touch. The hill is either going to be under or over, but it's not going to go through x. So type that into your calculator and let's look at it. Let's see if you can guess which side, is the right side going up or down? Right side goes up and both ends go the same way, yes? Okay. And then somewhere when it comes down to turn around in its hill, it's not going to cross the x-axis. So let's look at it. Oops, I'm zoomed way out. Let me go to a zoom 6. And what do we know it's going to do at 1? It's going to bounce at 1, right? So we know it's coming down. Why is my calculator going so slow? Okay. Calculator is stuck. There we go. So we see what it looks like. We only have one spot where it crosses the x-axis, and we knew it was a double root, so we knew it was sitting on the axis right there because that was squared. So start thinking about those things. It's a big help to you. All right, now we're going to find all the zeros. So how do we find zeros? We set it equal to 0, right? And we'll factor out an x. Now we say x equals 0, x squared plus 4 equals 0. So here we have x squared equals -4. So x equals what? Plus or minus what? 2i. Normally when we're not working with imaginary roots, we just leave this and we say there's no real zeros, but today we're looking at the imaginaries, okay? So graph this one on your calculator, and what do you notice about the zeros? What does it look like? Put that in. We want to see okay, so we have one real root, right? It looks like this. So that is one real root. Now, this is x cubed, so how many roots does it have? Has 3 roots, right? So 1 is real. That means, well, I'm spelling real wrong. 1 is real, so 2 are imaginary because we have to have 3. And we know imaginary roots always come in pairs, so we either have 2 or 4 or whatever we have with those, right? Okay, so far? That makes sense? Just adding those imaginaries. So anytime you have a power and you know how many zeros there are, if you can only see one of them or 2 of them, you can subtract to find out your imaginary ones, right? Okay. If you know how to do both, you can pick the one that's easier. Is it better to factor or use synthetic division? Let's try. All right. So if we factor this, right? You know what? Part of this is off. There's part of the given did not print out. Given 1, 0 is 3i. Okay, for some reason that popped off of there, but one of the zeros is 3i. So if we factor this, we could take x squared out. That's x plus 1. 9, we could take a 9 out and we get x plus 1. So we get x plus 1 times x squared plus 9, right? Grouping is not an issue. So x plus 1 equals 0. X squared plus 9 equals 0. X squared equals 9, -9. So x equals plus or minus 3. X equals -1. Start to write 3 again. So that's what factoring looks like. What does it look like if I use synthetic division? Well, if I know 3i is a 0, I'll put 3i out there. And we've got our coefficients 1, 1, 9, 9. We bring that 1 down. 1 times 3i is 3i. 3i plus 1 is 1 plus 3i. We multiply that, and we get 3i plus 3i times 3i is 9i squared, which is really what? -9. So when we add down, we're left with just 3i. 3i times 3i is 3i squared, 9i squared. And 9i squared is what? -9. So we get this. Now, if 3i was a 0, what's the other 0? -3i, right? So then we put our coefficients in. Now we carry that down, have 1. Now this is 1 minus 3i, which is 0, or 1, sorry. Oh, what did I do? Sorry about that. That's negative 3i times 1, that's negative 3i. When we add them down, we get 1. Negative 3i times 1 is negative 3i, which is 0. So we started with x cubed, then this would have been x squared. This is just x, so that's 1x plus 1, right? So we know the other 0 is, so we have negative 1 plus or minus 3i. I should have wrote an I on there. I said it, I didn't write it. So which way is easier, synthetic division or factoring? I think factoring's easier. If you had one that would not factor, then I would go to synthetic division, right? All right, so find the zeros. So how do we find zeros? First, we try to factor. Is this one going to factor? That one's not going to factor. So if one of the factors is x minus 1, what's the 0? X equals what? 1. So we could put a 1 out here. Now we have 1, negative 3, 4, negative 2. So this kind of really reviews a lot for us. 1. So if this is x cubed, that means this is what? X squared minus 2x plus 2, right? Now we need to either factor that or solve it, right? Right now we have this, but we need to finish this part. That's a quadratic now. The advantage of knowing one factor allows you to bring this from an x cubed down to x squared. Once we have x squared, can you solve any x squared? Yes, you can, because if this won't factor, and it's not going to because there's no two numbers that multiply together to give you 2 that add up to 2. But what do you have anytime that you have a quadratic? What can you use? You can use the quadratic formula to finish it out, right? Because it says find the zeros. So what is A? 1, B, negative 2, C is 2. So what do? X equals what? Negative B. So it's the opposite of B, plus or minus B squared minus 4 times A times C, all over 2 times A, right? So we have X equals 2 plus or minus, this is 8. What's 4 minus 8? Negative 4 all over 2. What is the square root of negative 4? 2i. And now how will this reduce down? If all of these are divisible, if every part is divisible, we can divide a number out. So we can divide by 2. And what does x equal? 1 plus or minus I. So we have 3 zeros over here. It says find all the zeros. So x equals 1, x equals 1 plus I, x equals 1 minus I. You don't have to write these 2 out. I'm just showing you that x cubed means we have 3 zeros. We can certainly write them like this, right? Once in a while, I'll have people that say, wait, I only see 2. It has plus or minus, so we write each one of those down. Okay? So imaginary numbers, We need to remember the square root of a negative number brings out an I. And if you have I squared, you replace it with -1. That's really the important part for you. All the rest of this is stuff that we've been doing, right? This is a repeat of the rest of the chapter, except we brought the I's in. Does that make sense? Are we good?